Welcome, everybody, to our webinar this evening on April 16th, 2025. It's our webinar for HVAC contractors on heat pump selection for rebate requirements and maximizing your success. I'm going to give you a couple informative slides here in the beginning about our sponsors and kind of rebates and things like that, and then we'll hand it over to our presenter this evening. Quickly, these are the rest of the webinars that are going to come up in our series. You can see we have them coming up for heat pumps and heat pump water heaters with ducted homes. Also, weatherization and electrification and how you think about that together to create and implement an affordable plan. Residential heat pump water heaters for existing and new homes we'll talk about, and then heat pump options for existing homes with radiant in-floor heating. So stay tuned for all those webinars. You can register at that QR code there. Thank you quickly to our sponsors, the Beneficial Electrification League of Colorado, Energy Smart Colorado, Holy Cross Energy, Tri-State Generation and Transmission, CORE, which is the Community Office for Resource Efficiency, our Energy Smart Colorado partner in the Roaring Fork Valley, CLEAR, which is the Clean Energy Economy for the region, Energy Smart partner in Garfield County, and then of course us here at Walking Mountains, we're the Energy Smart partner here in the greater Eagle County area. Quickly, this is a great resource for contractors and homeowners alike, talking all about heat pumps and electrification and best steps forward. Loveelectric.org. It's kind of your one-stop shop for all Colorado rebates and heat pumps. So they do a great job of listing all rebates around the state. So it's a really great first step if you're just looking for more information. It also has explanations and cost estimates for best heat pump applications. And you can also find a list of qualified installers of heat pumps on their website. Quickly about Energy Smart Colorado. Energy Smart Colorado works with 10 different nonprofits, and it serves 20 Colorado rural mountain counties. We'll tell you more about the 3 Energy Smart partners that are sponsoring this webinar and what their rebates are, but essentially the goal of Energy Smart Colorado is to make energy improvements simple and affordable. Here are the 3 Energy Smart Colorado partners that are sponsoring the webinar today: CORE, CLEAR, and Walking Mountains. Lists what their rebates are for heat pumps specifically, since these are heat pump webinars. This is a good reference for you to look back on if you're in any of these areas, and there's links there and phone numbers so that you can contact these nonprofits directly. Quickly, Holy Cross Energy, one of our sponsors, does have rebates for heat pumps. This page tells you all about their heat pumps for existing homes. So if you're replacing a current heating system, these are the kind of rebates you could expect to see for qualifying heat pump projects. And then this page is more specific to if it's new construction and what that rebate and that incentive total can be for electrification on a new home. And then quickly, so everybody knows that Holy Cross Energy does offer on-bill repayment now, specifically for heat pump projects. You can see the quick details on this page, and you can reach out to Holy Cross directly for more information, or any of those Energy Smart partners that have Holy Cross in their territory are also happy to help you. Tri-State offers on-bill repayment for heat pump retrofits as well. Low interest rates, terms up to 10 years, and no credit check. It's not available in all their locations. Right now it's San Luis Valley, GCEA, and Sangre de Cristo. Coming soon is White River Rural Electric. And they ask for you to reach out directly to those local providers to learn more about their on-bill repayment options. Excel Energy. Here's a quick page about their all electric new homes. So if it's new construction, they have some incentives available through Excel if there's Excel service. And then this page is specific to existing buildings if you're replacing another heating system in Excel and kind of those rebates available. But Dave is going to go through all of those rebates and kind of what that looks like in an actual real project. This is Dave. Dave's our presenter tonight. He has well over 15 years of experience in a range of renewable energy and sustainability business roles. He was the founder and president of Blue Valley Energy, a successful ground source heat pump engineering, design, and installation company in Boulder. And they had over 200 installations throughout Colorado. During the early 2000s, he led technical sales of solar and energy power systems for residential and small commercial businesses at RMS Electric. At Gold and Aluminum, one of the largest single site industrial power users in Colorado, David was responsible for leading adoption and implementation of a facility wide energy monitoring system and upgrades to reduce energy consumption on large industrial production processes. Most recently, he did consulting work with Excel Energy, helping customers understand their energy use. And in 2017, he launched NTS Energy, a consulting company focused on providing advanced HVAC and solar solutions to homeowners and small commercial companies while promoting the transition to the new energy economy in Colorado. Dave holds an MS in geophysics from Washington University in St. Louis and a BS in zoology from SUNY Oswego. And Dave, I'm going to let you take it over.
Let me explain why I put the zoology there. I don't know. I love my animals, so gotta put that on. All right, let me just switch the sharing here.
Oh, do I have to stop, Dave, or is it?
Yeah, you do. Yep.
Okay. All right. That was the wrong stop button. It's like I've never done this Zoom thing before. Dave's like, Nikki, it's like you forgot how to do all this. It says I'm not sharing. Am I still sharing?
Oh.
I still am sharing. Oh, wait, here. I got it. Done.
All right, there you go. Okay. Let me see if I can get it right now. Can anybody? Oh, no, I can't see that very well. Can you?
Yeah, we can see that.
All right, we can see that.
It looks great. Yes, looks great.
Okay. Well, on the other monitor. So we got a lot to go through, but I think I'll be able to address some of the reasons that you folks are hoping to get up and came on and open some of the stuff. We'll talk quick. We'll set it up. We'll talk about the rebates and what the levels of systems. And then I'm going to get into the details of sizing, which, Catherine, that might help you. And it kind of relates a lot to Manual S. Manual S is a real strict kind of system, but you have to sort of think beyond that. And then I'll go through some just back up and look at general strategies and then some other installation tips, etc. I think one of the first things to think about here, though, is I like to step back, and this is to show a lot of consumers also. And this on the right, the upper right is the bottom axis is outdoor temperature from 0 to 70, and the vertical axis is the percent of annual heating. And this is Eagle County, but also, Tom, this would be the way it would be in your area. Also, Tom might be a little shifted, but I want to point out a couple things. From 35 to 65 is 1/3 of the annual heating consumed. And then from 15 and below, we always think, wow, that must be where we always use a lot of energy. That's only what 1/5. And then the big chunk is in the middle, 1/2. So that really, I think a lot of people don't quite feel that, it's kind of an eye opener in a way. And this down below you can look at is just the months. And you can see that a lot of months, even up in Eagle, are above 30 degrees. This diagram on the left then, a lot of the questions are heat pumps going to save me money versus gas furnace? How do they compare? And of course, there's so many variables, it's hard to generalize. But this is kind of my best attempt to try to explain that. Again, the bottom is outdoor temperature, and the left axis is called COP, which is coefficient of performance. For every 1 unit in, how many units of heat you get out? And basically, heat pumps move heat, so they can move more. And so what you want to look at here is this top dark line is an air-to-air heat pump, sort of a standard mini split. And you can see when it's very warm out, I mean, they can move 4 to 5 units of heat, and then it gets harder and harder. When you get way down to -10, -15, it's about 1.5 units. And in this big area, the 50%, it's right around 2.5 to 3. Now, how do we generalize? So, but in this 1/3 area above 35, heat pumps, I'm going to say, normally lower cost to heat than gas furnaces. And what I mean normally, what I mean is, if you look at the price of gas over the last 10 years or something, and when they price gas where they're not losing money, when they're breaking even or making money, because of this efficiency gain, heat pumps are lower cost. The opposite end is down here in the 18%, but it's a lot smaller percentage. You know, gas prices, we do keep them low in general. And you look at the last several years, you know, normally in this range, it is less expensive to heat with gas. The middle range, the big one, is the interesting part. And it depends on where you live, what your zone, what your climate zone is, and what the prices are. It goes back and forth. But generally, you can say that they're kind of close, plus or minus 10% any given year. So, so really the key thing here is combining heat pumps as part of a system. Heat pump-based systems are always going to save some money depending on how you design it and put it all together. Now, I want to make sure we're on the same page with communication. There's really three levels of heat pumps. There's the sort of the single and two stage, and these are, let me call them the classic heat pumps. You know, and this thermometer here is the efficiency. So lower efficiency to higher efficiency. HSPF is the heating efficiency. SEER is the cooling, and they're kind of paired. You can't have a super efficient heating unit and a terrible cooling. They're really paired together pretty well. And you can see the 1-speed and the 2-speed, there's some overlap. But these are really for ducted systems only, and they're not adequate for all electric heat pump heating in Colorado. They're just, they don't have the capacity, and they tail off. But they're okay for existing homes in particular, and for some reasons, if you have gas in new homes, called a dual fuel option. It is an option. It's sort of the low cost option, not the most ideal. There's two kind of variable speed inverter systems, which you're going to see when you go on all the system sites and when you look through whoever equipment you're repping. You know, there's the inverter systems. I'm not going to call them non-cold climate. You know, they work down to 0. The difference is their capacity drops off at lower temperatures. So if you have something that's called a 4-ton system at 48 degrees, at 0, it might only be 2.5 tons of capacity. So they're not, again, because of this drop off, they're not really ideal for all electric heat pump heating in Colorado because you would depend a little too much on the supplemental. But they're all a very good combination when you combine them with in existing homes, particularly with dual fuel. The last one are variable speed capacity. These get the label cold climate. And the main thing is they hold their capacity at low temperature. So if it's a 4-ton system at 5 degrees, it's going to basically be about 90% of that 4-ton. And that's what you need. You need these for all electric heat pump based systems. And they heat down to I kind of use Mitsubishi as the standard. Colorado, they've been sort of leading the charge, and so Mitsubishi goes to -13. Other manufacturers you might carry might vary a little bit, but that's really where we're at. And then these are really what's required if you're going to get all electric system rebates. Now, Nikki had a much more detailed slide, and I've put a lot of this in, but I really want to simplify it. So there's really energy efficient systems, which are sort of level 1 and level 2, single, multi-speed, and XL and tri-state. These are for retrofits, and here's their requirements. I think the key thing I've highlighted in red is, okay, in order to get those rebates, they really have to have an SHPF of 2, of 7.8. So you got to have that level. Then you've got cold climate, ducted, and mixed. These rebates, XL has quite the rebate this year. It's a 1-year sort of experiment. Holy Cross has some good one, and then Tri-State is per ton. And I actually noticed when Nikki showed the site, it seems like if you sign up for their on bill, they have different additional. Notice that's a leap up to 8.1, 8.2. I think when you're thinking about these levels, that's what you got to think about. And the capacity for a couple of these has to be 70% at 47 degrees, which really is like the cold climate. In fact, this is a little, I would have put this a little higher, but they're giving a little more leeway. And then, of course, the non-ducted, the mini splits have a higher HSPF too. So really what you got to think about here is if I'm looking at my equipment, I want rebates 7.8, 8.1, 8.2 with no capacity levels. New homes, it's a more, the rebates are more favorable. XL starts with next gen Energy Star homes, 10,000, and there's even higher levels for even higher levels of homes. Holy Cross has 15,000 for all electric appliances. All that won't go to the heat pump, but a lot of it would. So for new homes, there's a very good. So really the system goals, as a contractor, I'm sure everyone could agree, we don't want any problems. I don't want any callbacks. And the homeowner's got to be comfortable under all the conditions, and it's got to meet their expectations. And it's a trick because here you've got to balance first cost, energy use, operating cost, selling advantage. In the past, we're so used to we're very used to really inexpensive, low cost heating and cooling for most of the time, last probably 80 out of the last 100 years. So this is a little bit different game. So typically, there's been three big issues that I would say that I've encountered through other people and talking the most. I'm sure there's other issues, and it'd be nice if either of you have heard of other issues. But here's number one. In all electric systems, people say, especially in existing homes, they're like, "Wow, my utility bills in the winter are crazy high, hundreds of dollars." Super high electric bills. What exactly is going on? Well, it turned out that the heat pumps were not sized to carry the full load at 0 to 5. In other words, it was probably that intermediate level heat pump. The capacity tailed off. What happened? A lot of electric strip use, a lot of it. So that's sort of one of the big ones. The other one is dual fuel and retro and new homes. And a lot of people will do these for cost, or it's they want to have a little gas backup. They want to make sure they get the gas backup, but they don't want a lot of gas use. And so what will happen is they'll have expectations that their gas use will be cut by 75% or more, which when designed correctly will happen. But the changeover temperatures get set too high. So rather than have the heat pump size so it carries the load down to 15 or 20 degrees in existing homes, so you're using a lot less gas. You're only using it in that 18% region I showed in sort of that graph. They're using a lot more, and it's because historically heat pumps 30 degrees set the changeover temperature to that. So that's something where you as a contractor, and we've got to just talk with the customers more and have them understand how to adjust their changeover temperatures, maybe be a little more aggressive. And finally, all electric retrofits. Most of the duct system supplies and returns are designed for high temperature heating from furnaces. And heat pumps just do not put out that much high temperature. So they need more airflow, anywhere from 20 to 30%. The ducts have to be bigger, need more airflow. Well, if you don't have properly sized ducts, if you don't have enough supplies, and it's particularly returns in these situations, what happens is it flips over to the electric a lot more because you're just not getting the BTUs and you're not getting the temperature up. And so that's the other thing. It's not paying attention to what the distribution system. So these are three. This is from the consumer point of view. I'm sure there's a lot with the contractors in terms of commissioning, etc. So let's get into the nitty gritty here, and this relates, a lot in a way to Manual S and sizing. This has a lot of information. Minus 30 to 7 degrees is outdoor temperature on the bottom. 0 to 60,000 BTUs per hour. That's heating load. And let's look at the dark red line would be manual J. I put in sort of a standard house, couple thousand square feet way up in the mountains, medium, insulation, etc. So now everyone talks about, and in the industry, there's kind of, oh, manual J overdoes it, etc. Now, as a contractor, I don't necessarily count on that, but there is a range of uncertainty in how a house would perform versus what the computers. So that's what I've tried to show here is this, 10-15% range of uncertainty. The house might do better, might need less. Rare, but it might actually need a little more. The second part, which is the heat pumps. And so you can look in all the engineering specs, and that would be this green. This would be like a cold climate heat pump, Mitsubishi Hyperheat, stays up till 0, and then it does tail down. Now, for many reasons, that's sitting in a beautiful factory floor with perfect line sets, not very long, etc. In the real world, you've got longer line set, you've got outdoor conditions, icing, wind, various things. You've also got duct system inefficiencies. You've got degradation over time. So you've got a range of where this is going to operate in reality. So now you come down here and you say, well, okay, in the high country, the manual says, oh, size it to -1. Well, what you really need to do is, especially if you're looking at electric backup, is, all right, I've got to think about this is kind of the ballpark area. So, all right, I'm in here. I've got this size unit. That's matching up pretty well, but realize I've got to make up for some of this differences with my backup. With gas, it's not as, your penalty is not as much because of the cost of gas is not very expensive. Now, the other key thing in this is looking at the number of hours and what's the risk involved. As we're designing this, the customer has to be comfortable. I should have actually put a big 4, as sometimes they're not comfortable when it's super cold out. This is hours per year on the right side. This thin black line, which I probably should make a big black line, is over the 30-year climate. This is the number of hours per year that it's in that temperature range. You notice once you get below 0, that's below 80, and then it gets down in here and it's below like 20. So the way I like to think about it is, sure, this is maybe 5 to 10 nights a year, and this is when we have polar vortexes and maybe a couple nights a year. Not a lot of hours. So, when you're in here, you shouldn't be running electric a lot of hours. When we get way down here, we're talking about very few hours, talking about houses holding. So when we're sizing this up, trying to summarize a little bit, if it's all electric for new homes, you're going to have to size, and for existing homes, you got to size that whole climate to meet the full heating loads down to -5 to 10F. They've got to carry the load because I don't want the electrical to use less than 10%. If you got retrofits, existing homes, you can size the heat pumps. And this has to do with the ducts. Do they want to invest a lot in the ducts? A lot of people sometimes can't afford to invest in upgrading all the ducts, or it's difficult. So you might size it down to 15 to 20. Then the temperature is going to switch over. And as I explained in one of the slides, as long as a customer, you want to teach the customer, I'm going to set it to 25. If you're comfortable and you think you want to try to use the heat pump more, you can set it to 20. The other thing is when let's say prices go crazy one way or the other, you can move that. But if you got propane or electric supplemental, unacceptably high bills unless you significantly upgrade the duct system. So the other thing is there's a lot of work the last 20 years in terms of don't way oversize systems. And that comes from historically With furnaces, it costs a couple $100 to throw double the furnace size. Never worry about it. And it'll be not much efficiency difference. Well, here with heat pumps, it's not huge efficiency differences, but you try to want to keep it because you don't want to overbuild ducts. You want to keep it to the correct size. But we don't want to be you don't want to be overly cautious. So if in sizing it, if you're using manual J and it comes out to be, let's say you've got a 44,000 load or 45,000, 46, and you say, well, maybe I can do a 3.5 ton. All right, you might want to up it to a 4 ton. Efficiency wise, a few percent. And it could be one way or the other, depending on how they tune the system. So, and you're also going to remember over time, you're going to have some loss of capacity. So if the load gets to be a little more above the unit capacity at the design, you might want to consider upping it a bit. Otherwise, you have to put a little more electric. And remember to compensate for altitude. And I think it's good practice not to assume anything about maintenance. So let me go through a specific example with real hard numbers here. This is Eagle up here in the top. This is the percent of the annual heating load. So 99% means above 1 degree outdoor, 99% of my annual heating, 99.6. This is the mean extreme over 30 years. And this is the lowest heating bin. So I don't know why in their thing, the mean extreme is a little different than this. But so this is what you have to do. And here's the number of hours. So on the average, not a lot of hours. Now we have a couple polar vortexes. This number might go from 2 to 15, might go 3 nights a week. Here's a house heating load. This is the heating load, goes up. Here is a Mitsubishi Hyperheat 4-ton unit, altitude correction, 6%. And you can see it drops off. It's short. Well, what's the shortage? Here's what it is: 7,000, 14,000. I'll talk about this in a minute. So how much strip heat? 2 kW, 4 kW, and this is the amps. This is not a bad amount. This is not going to cause the utility a lot of heartaches. But now you've got a couple hours below here, and depending on which product you're using, I'm using Mitsubishi as the standard, -13, some now -15, some -12. It goes down, it'll keep it warm, but then it won't turn on again if it's still below there. So a lot of people in the past, myself included, when we put these ground source heat pumps in 15, 20 years ago, say, man, I got to carry this whole load. Well, that's really not acceptable and not what the utilities can handle. This itself would be 16 kW, like 72 amps, means it's a crazy amount. Now, one thing is not so bad is you take this, and I have 8 kW, which is not terrible. And I can keep, for the few hours at night, the house might cool down some, but it's not gonna go to freezing, or it might go in the 60s, maybe in the upper 50s, but it'll bounce back, especially these new homes. So you can't way oversize this. And in the next slide, I'll show another way to share a couple circuits. Now, in Denver, it's a better situation. Same numbers, a few hours, but it only goes to like -13. And so really all I have to do is share it. So I've got, I don't really have to worry about the situation where it's just below the capacity of the coldest temperature. So if you don't have gas on site and in a new home or a retrofit, you got to size the strip to make up the difference. You size and make up the difference. So 3 to 8 kW is pretty good. A lot of the newer homes have very nice other backups, which you can count on to some extent. If you really feel as a contractor you need to go to 10 kW, you can have it staged as 2 5 kW circuits. It means you might never use the second one, but that doesn't really help the utility. If it's more than 10 kW, I would put in a couple, size the heat pump, or I'd actually put in a couple of heat pumps. Now, you can share with EV charging circuit the backup of a heat pump. It's a great way to share. the few nights a year that you might need to call that backup circuit for, uh, a couple hours, okay, so the EV charging cycles off. And 40 amp gets you an 8.8 kW, which is big. There's a simple switch we can use now. The other thing is Holy Cross and other utilities are looking at the smart electric panels, being able to share these circuits. That's really critical. That's important. But I would talk to the utility about the financial technical support. Where are they right now to make sure that you're not getting out in front of the curve? If you're new construction, you can design the ducts correctly. You can size them. So you want to be more aggressive. You can do a cold climate heat pump. And this is just the case where the clients say, I want a furnace. I'm going to have gas no matter what. And that's the way I want it. So you can basically say, all right, fine, I'll put a cold climate in. It'll do almost every bit of heating, but hardly ever use the furnace. You can just size the furnace for super. I mean, really, in this case, I don't consider it a furnace. I consider it the air handler with a little bit of backup heating from the gas. Mini split's really important here because it's really important because you got to size every indoor unit by itself. You got to make sure they fully heat that room down to the minimum temperature. The other thing is you can't have a wide divergence between the sizing. Like 1 ton is really, you can go and I can put in some 1.5 ton and 2.5 tons. I can't put in like a 1 ton and a 3 ton system. Indoor units, you can't have this deviation in these multiple units. Usually 2 to 3 units is a really nice trade-off between first cost and efficiency. You'll see, obviously, and some of you might already handle it, and maybe you're putting in ones with 5 or 6 or 7 heads. I don't know of many people doing that. The most I've known is people can balance out 4 units. So strategies. We talked about whole house. We've been talking about ducted. The heat pump strategies, you can use an air source or a ground source. Obviously, with the ducting, the thing about the ducting, when it's done well, it's there for the life of the house. So it is something that's not going to have to be changed as systems evolve over 50, 60, 70, 80, 90, 100 years. I'll talk a little. I have a couple slides on ground source here. The last seminar of the series, I'll go into ground source more completely. Mini split with a whole house. The difference here, I think, is you can't get the fresh air and the humidification as part of the whole system. There's more equipment to maintain. You've got all these indoor units. Sure, there's less ducting and architecture is easy and construction sometimes is easier. Radiant in-floor heating for winter in combination with air heating and cooling. You can do boiler and air source. You can do ground source, air source, hydronic. I have a couple slides on the hydronic, which I'll touch on this time. I think another big thing, a lot of the clients really still want, especially in the high country, want the radiant, but the reality is the comfort difference has collapsed a lot with good walls, good windows, super insulation, nice, consistent low flow ducts, zoned, etc. This comfort factor is a lot. The air ones are really comfortable now. I think the only thing here I want to touch on is, in the past, the design was always, all right, I'm trying to keep the one system. I think now, you got to look at each floor. And I think in a lot of cases, it really lends itself a really nice small heat pump in the second floor, be it ducted or some mini splits. In the main floor, then, you got to look at what's available for ducting. Am I going to do traditional ducts? I could do some mini splits in there. The basements, especially with new homes, I think the energy use is so low, they're so insulated. The bigger concern is making sure there's fresh air coming to all those rooms all the time. And you really need very little BTU. So you can actually use ERVs with little electric heating. And zoning is really critical now. I think the days of one thermostat for the whole house are pretty much obsolete. You got at least one for each floor. And if you've got big windows in the south, no wind, everything in the north is bedrooms, you might want to zone it out. I'm not going to go through this in great detail. I think most of you know about all these mini splits, the wall units. The slim ducted are really nice. A couple situations, obviously you can put them in closets between two similar sized bedroom. One unit serves both. Put them above bathrooms to do different ones. These are pretty nice. They're more for commercial, but these ones in particular can fit between the joists. So those work really well in some houses. I haven't seen many of these. I don't know why. Really not. I don't see them put in the U.S. But then with new homes and with good woodworking, you can do a nice job making these kind of units fit into the home. For a whole house system, a mini split, they're good for small homes. I mean, realize you kind of have to have a head for each room. And, Tom, we were talking about your project at the beginning. This is probably what they did. They had the bedrooms, they put ones in the bedrooms, and they put one big unit in kind of the kitchen, living room, open area. For little rooms, electric baseboard, little electric toe kick heaters and stuff. Small rooms, you can do that. And then, that's much more cost effective than trying to do more of these wall units for something that hardly uses combo. In the front range, I think it's becoming more common to really talk to the folks about where do you want rating. I mean, if the core of the system, if you care about cooling, if you care about indoor air quality, if you care about energy efficiency, trying to lower your bills, you're going to do some kind of a heat pump air system. That's going to do a lot of heating through 3/4 of the year. And the question is, what do you want in the winter? What rooms do you want warm? Do you want it from radiant? Do you just want the floor warming, etc.? So it's just a little more discussion. And we talked about the heating sources. Ground source, I'm going to 2 slides on that. It's big, huge houses. It's expensive, but for really big houses, it's a good one. Air to water hydronic is really kind of, I'd say, a niche product. If you can get a house where with one of their bigger units, you can do all the radiant and the ducting with that, it might be worth it. Or sometimes you can combine it with a boiler just to get a little more energy efficiency than just a pure boiler system. So 3 slides on ground source. There's the standard air units. That's on the left side. On the right side is hydronic units. So there's a smaller one. You got a tank with all the hot water. Often you might have a little electrical in there just to keep it constant rather than kicking the unit on all the time. Very little, less than 5%. Now, if you want to use this, you can use this in combo to cool also. You would put another tank over here and have it a cooling tank and go to air handlers. Sometimes in the past, they've used one tank and it flips back and forth. Sometimes it's hot, heating, cold. Colorado, I don't recommend that because we have a lot of swings in the days and we have a lot of swing seasons. This unit in the middle is great. The manufacturers make a combo, air and radiant hydronic system for the tank for heating. So this is, if you're going to go ground source and you want to do the 2 of them, this is fantastic combo. 1 piece of equipment, 2 major tasks. Just a quick thing about loops. Horizontal loops was where ground source started in the Midwest. Moist soil, lots of land digging, not so much in Colorado, maybe in the Eastern Plains, maybe out North Grand Junction. Our soils are drier, so moisture helps these work more efficiently. You need to have bigger loops. Everything's vertical pretty much. I usually do a borehole per per ton, typically 5 to 6 inches diameter, 15 feet apart. Done tons of these. You can fit them in the tiniest places in Denver, older Front Range cities, Colorado Springs, all over. But very complicated geology. All you got to do is look at a geology map of Colorado. So the ground source, the installation cost is up there. You have a 30% federal tax credit through this year at least, and so the rebates are substantial, which helps offset the cost. Air to water is very similar to, as you all know, air to air. Maybe bigger units. Instead of going into air, it has a heat exchanger into a tank. These work pretty well. In Europe, this is a very big system. Lots of them, they're more standardized. We have some from Canadian systems. I think the key thing here is you got to make sure you derate the outdoor unit. And the other thing is designing the in-floor. It only really works for in-floor radiant. Make sure that the radiant is designed to run low. Like this is entering water temperature at 95. I got a COP of 3. If I go up to 115 or 120, I lose 20% of my efficiency. So the floors have to be designed to run at low temperatures. We've had a client's running his floor at 104 through the middle of winter. Is very happy. If you're going to combine this with gas, you've got to make sure that it heats for down to 20. The heat pump does most of it, 20. If it's electrical, you've got to have the heat pump heating down to 0. Got to have the capacity. Their costs are in between. They're more than air systems. They're less than ground source. The disadvantage is that they don't have the 30% federal tax credit. I should say the utilities right now for ground source, Colorado, the utilities have pretty decent rebates for ground source. These pretty much are parallel to the air source. So the big $1 million question always is, am I going to save a lot of money and what's my payback? So this is one house, very consistent, right? Sweet. It's a couple thousand square foot, well-insulated house up in high country. It's an Eagle, and the big elephant in the room is what energy costs do I use to do the model? And so using individual year costs, as you all know, especially gas jumps around and electricity does some of this, isn't really the best way to answer the question. I think the question is, what's my cost to heat going to be over the next few years, over the foreseeable future with these two technologies? Foreseeable future, let's say 5 years. And so the way to do that is average it over the last few years. And so this is from 21 to 24, December Colorado average. This data is from the Energy Information Administration. They take all the utility residential data every month from all the states, combined it all, and come up with an average cost for that state for residential gas, electric, and they don't do propane. I've just taken propane. It's usually 2 to 3 gas. I've just did it twice to be conservative. So this is like over the last 4 years, how are these prices? What about are they going to be? This is a gas system. This, and it's 1,659. Now, if this was propane, if I use double, that would be 3,300. So remember that number, 3,300. This here is a cold climate heat pump with a propane furnace. I can put gas in, it wouldn't make much difference, electric, because I'm doing almost all heat pump. 1,586. So propane was 3,300. Gas was, with the heat pump, propane is 1,586. Saves tons of money. This is a 2-stage heat pump with a backup furnace. I think I put 25 changeover. And you can see the price about the same. And this is a cold climate heat pump with electric, and it's actually a few percent lower, about 6%, 6% down. So this is using, what have these prices been over the last few years? And, they're going to stay relatively consistent because over time, these industries can deviate in a given year, but they kind of have to hold the line. So this is installed in And these prices always are hard to generalize because front range is different than high country. But now, if you have a furnace with air conditioning using about $20,000, there's really not any rebates, maybe 250 or something for that efficient furnace, but nothing so much to speak of. All electric, cold climate, new house. So these numbers, this could be about 8,000, 9,000 more, something like that. Um, Other people might have different numbers, but it's a dynamic changing event, but try it, get feedback. You try to figure out what's realistic. Um, Now there's big rebates, $10,000. And that's basically they're in the range of 5 to 15. Holy Cross has 15 for all the electric appliances altogether. Most of that's going to be the heat pump, XL 10. And then you've got a federal tax credit. So basically you're below. Minimally, I can say you're pretty much in the range. A retro, you got 28 now. The rebates vary a lot with the retros. I've got a range. Some of them are 2 or 3,000. Excel has a great deal this year. I go out and get it, 9,000 on a 4-ton. So I put kind of an intermediate number, 21, with the tax credit. So you're basically, I'm going to say some are lower and some are on par. And then finally, a dual fuel with furnace supplement. You don't have near the rebates, but you're in the ball. So I'll finish up here really quick. This is just some quick stuff you all probably know about in terms of installation to help have success. I'd say placement is kind of nice if you can get it on the southeast side, the south side. The sun helping defrost. Also trying to protect it from the wind, the west wind direction, either soft or hard landscaping helps. You want to be concerned about noise. I don't want to put it under bedroom windows, or I don't want to mount it on walls of bedrooms. The other thing is it's a little bit interesting because you want to keep your line set runs at minimum if you can. So sometimes it's a little hard to balance that out. You got to keep it up high. You don't want to have the customers shoveling it out. Up in the high country, the average. I kind of look at the average snow depth of at maximum month. Say I want it to keep it above that. So that's a few things there. Everybody I think knows about ducts. Make sure they're good. I think understanding the zoning system, making a good zoning is important. And this a little more about mini splits in terms of refrigerant lines, condensate lines. There's been some clients and folks talking about 90 degrees in these condensate and the refrigerant lines. All of a sudden, hard 90s in refrigerant lines. That doesn't work well. People putting condensate lines sagging, ice on sidewalks, etc. I do need to talk about the changeover this year. Basically, probably by the end of March, there won't be any more R410As in production. These new refrigerants, they are the driver was there's greenhouse gas potential. In the manufacturing process, these things are very GHG intensive. So that's the big drive. They're slightly more efficient than R410A, a couple percent. So you're going to have to look at your refrigerant tools. Some refrigerant tools can handle multiple types of refrigerant. Looks at about 2 to 3K. They have new tools, also specific lubes. Piping, if your line sets are the right size for the new system and they're in good shape, they can be used as long as they're totally cleaned out. But you can't use existing coils. Got to be concerned about the storage and safety, or some additional limitations there. There's lots of information out there. This guide, this clip here is very well written. You can really get to different parts of it. I think it's a good referral to tell you what's gonna be involved in this changeover. And obviously, this drive for heat pumps is it's energy efficiency, use less energy. A lot of folks out there care about these things. Some don't. It's a wide range of views, obviously, but there's the heat pumps significant air pollution, NOx, VOC, sulfur particles, et cetera, in the front range. This stuff all adds in. GHGs. So, we're talking about the next 15 years. So combining a heat pump, having a heat pump based system, be it all electric or a combo one, really will cut back on this stuff for the biggest component here, space heating. And these are really very efficient space cooling. So, and that's kind of, that's all I've got today. And that's just kind of a summary. So take some questions if y'all are still here. Thank
Thanks,
you.
Dave. I think we're happy to take questions if anybody has any. Catherine did ask during the presentation, is there a specific changeover temp we should be aiming for?
I think David answered the question.
That's what I thought.
Following
Okay.
slide. So this was for the dual fuel, and he recommends a range of 15 to 25.
Yeah, that's what I need for. And just to tell you, usually what that involves with the ducting is to add a bigger return, which it's not usually that difficult to figure out how to get a big return. And usually it might add like 3 or 4 supplies. That's a little more of a challenge. So, but yeah, shooting in that range is good. For new homes, if it's a dual fuel, go for 0, go for like 5 or 10 or 0, because you're going to build ducts from the scratch. So you don't have that limitation. So you might as well use the heat pump all the way. And then, they just use the furnace as an air handler. And when it's super cold, they use it a bit. That's all.
Anybody else have questions?
Tom, did you get any information on that? Do you think help you out?
Oh yeah, I got plenty. Thank you.
All right, excellent.
And there is one thing I might tell you guys. You might maybe adjust your slide on the tri-state. I believe is at 1,500 not per ton now, as of 25.
1,500 total.
Yes.
Okay.
That it was 500 a ton in 2024, but it adjusted in 2025.
Okay. All right, I better look at that. Thank you. All right, well, we consumed our entire hour. So
I really appreciate you guys doing these. So I look forward to getting these links out there to more people as well.
Great. Nikki, you're still on mute, by the way.
Thanks. I just said thanks, everybody, for being here. I think it was great information. So you're welcome to reach out to us later if you decide you have more questions for Dave, and we can get him to answer those.
Yep. Thank you, everyone.
Thanks, everybody. Have a great night.
Thanks. Bye.